Hey, how you doing guys? It's Ilya Belly here. I record stuff on YouTube. Check the description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel, give me a big thumbs up to support it. And this is called the Skyline problem. This is the hard one. A city skyline is the outer contour of the silhouette formed by all the buildings in that city when viewed from the distance. Now, suppose you're given the locations and height of all the buildings as shown on the cityscape photo figure A. Write a program that output the skyline formed by these buildings collectively. Figure B. The geometric information of each building is represented by a triplet of integers Li, Ri, Hi, where Li and Ri are the x-coordinates of the left and right edge of the ith building, respectively, and Hi is its height. When I talk about Li, I mean the left pointer, Ri the right pointer, and Hi the height. It's guaranteed that 0 is less than or equals to the left pointer, the right pointer is less than or equals to integer max, 0 is less than the height, and the height is less than or equals to integer max, and the right pointer minus the left pointer, this value is greater than 0. You may assume all buildings are perfect rectangles grounded on an absolutely flat surface at height 0. For instance, the dimensions of all buildings in figure A are recorded as 2, like the left pointer, 9, the right pointer, and 10 the height. You can check this out. The output is a list of key points, red dots in figure B, in the format of the left pointer, right, and the height that uniquely defines the skyline. The key point is the left-hand point of a horizontal segment, and note that the last key point where the rightmost building ends is merely used to mark the termination of the skyline and always has 0 height. We're talking about this one. Also, the ground in between any two adjacent buildings should be considered part of the skyline contour. For instance, the skyline in figure B should be represented as like the left end point, right? The left pointer and height. The number of buildings in any input list is guaranteed to be in the range 0 and 10,000. The input list is already sorted in ascending order by the left x position left pointer. The output list must be sorted by the x position. There must be no consecutive horizontal lines of equal height in the output skyline. For instance, 2, 3, 4, 5, 7, 5, 11, 5, 12, 7 is not acceptable. The three lines of height 5 should be merged into one in the final output as such. 2, 3, 4, 5, 12, 7. Well, let's start. I'll show you how to do that. First, you need to create the list containing the result. New array list, type list, integer. Finally, just return this result. You create a list. It's called height. New list. And right here, you are looking through these buildings. Row by row. and there is kind of like a trick, I would say. You say height dot add create new 2D array containing the left pointer be at 0 and be negative height. When we are talking about the negative height, that means we're talking about the left pointer, right? There is a left pointer into this 2D array, right? And we do the same right here. We can copy that and paste and say instead of the left pointer we use the right pointer and we get rid of minus. When we talk about the positive sum, the positive height, we mean the right pointer. We need to sort collections. We say collections dot sort this height in increasing order according to either like first, like left pointers or just heights. In the case when a at 0 the left pointer doesn't equal to b the left pointer, we just pick up the smaller one otherwise if they're the same, we say a at 1 the height minus b at 1. Next, you need to create a queue, priority queue. There is a heap data structure like big of n log n time, but if you use priority queue, this could be implemented by like this could be implemented in big of log n time. I mean operations like remove and offer, right, are implemented in big of log n time. So you can say priority queue, new priority queue, type integer, and right here you say a b b minus a, because we want to create this queue such that this queue returns the element with the highest priority, right? Yes, that's it. So we need to offer 0 initially. We create a previous and we just are looping through this height. Again, row by row, right? So we say in the case when the height is negative, we are talking about we are sure that there is a left pointer right there, so that means that we can offer that height, that positive height. Otherwise we need to remove that height from that queue, and every time we pick up the element with the highest priority from that queue, maximum element, queue.pick. And in the case when previous doesn't equal to the current one, you can create list, temp list, new array list, integer, and you say temp.add the left pointer and temp add this current height. And finally say result.add this temp list, and also previous equals to the current one. Finally just return the result. That's it. So you just create the result right here. You create a new array list, by the way, new array list, create a list height, right, which contain the left pointer and the height. You're looping through these buildings, you add the left pointer and the negative height, and the right pointer and the positive height. You sort this height such that like, you know, in increasing order, you compare the left pointers. If they're not the same, you pick up the smallest one, and you otherwise you just pick up the smallest one, but according to heights. You create priority queue, which returns the maximum element. You offer 0. You say previous equals to 0 initially. In the case when like we know that there is the left pointer, we add the element to that queue. We add positive height into that queue. Otherwise we just remove that element from that queue. We say current the maximum element from that queue, and we add the left pointer and the current height, and we set up previous to the current height. Finally we just return result. Yeah. And let's run this code. Hope that works. There we go. Accepted. Good. Let's submit. Success. Good. So let's look at this example. Like, we have two, like this example, right? Height, initial result is empty, height is empty, right? So we will have height, right? And here we have like we say 2, and we say b at 0 equals to 2, right? So we just add 2 right here. Minus b at 2 will be minus 10, 10 minus 10 right here. And also b at 1 equals to 9 right here. We say 9. And b at 2, the positive height, equals to 10 right here. And you keep doing the same, you know. At the next iteration will be like 3 and minus 15, then 3, then 7 and 15. Then at the next iteration you have 5 and minus 12, yes, and you have 12 and 12. You have 15 and minus 10 right here. You have 20 and 10 and 19 at 19 and minus 8 and 24 and 8, 4 and 8. So 2 and minus 10, right? 3, 9 and 10, 3 and minus 15, 7 and 15, 5 and minus 12, 12 and 12, 15 and minus 10, 20 and 10, 19 and minus 8, 24 and 8. That's right. Next, you need to sort these according to the left pointers, if they're the same, right? So you just, otherwise you just according to these heights. This will be something like this. You can say right here, right? Like right here. 7. All right. There it is. There we go. 9. Goes here, and so we have the list looks like this. As you can see, like the left pointers are in increasing order, right? And after that you create a queue right here, initially with a queue 0 element, order like from right to left, right? So previous equals to 0, and we start looping through these heights. Initially we are here, the position of 0. You know, like height equals to minus 10 is negative, so we're talking about the left pointer. So we just we add the positive height to that queue. We say like 10, right? And current equals to the maximum value into that queue, then which is 10, then previous doesn't equal to current, so we say add h at 0 equals to 2, right? Equals to 2. So we can say something like the result equals to 2 and 10, and previous equals to 10. Next, you can see that like there is, right, we are doing like the same right here. We are at this station, right here, 2 and 10, 2 and 10. Next, we go to the next element. We add 15, the positive value, to that queue, 15. Then current equals to 15. Previous doesn't equal to current, so we just say 3 and 15. 3 and 15, and previous equals to current, so equals to 15, right? You can see that we are here, 3, 15, 3 and 15, right here. Then go to the next element. 12, we add 12, and previous equals to 15, current equals to 15, because 12 goes before 15, right? It goes here. Previous equals to the current, so we just skip this step. We go to the next element. We go here, and we can see that the height is positive, that we see the right pointer, which is 7. That means that we need to get rid of 15 into that queue. We just remove 15, like here, right? And current equals to 12, right here, 12. Previous equals to 15, and current equals to 12. So just say 7, and you say 7 and current equals to 12, right? Equals to 12. You can see, you can check this out, 7 and 12, right? So we are here, like 7 and 12, right here. You can see 5, 7 and 12. Next, previous equals to 12. We go to the next element, which is here. the right pointer, so we'll just get rid of 10 into that queue. Get rid of 10, right? And the current equals to 12 right here. Update to 12. Previous equals to 12, current equals to 12. We skip this step, we go to the next one, go to here, 12 and 12. We need to get rid of 12. So current equals to 0 right here, and previous equals to 12 doesn't equal to 0, so we just say 12 and current 0. Previous equals to 0. We are right here, 12 and 0, right? 12, 12 and 0 right here. And previously we was like here, 12 and 10 here. And then we go to the next one right here. We need to add the element to that queue, 10, and current equals to 10. 10 doesn't equal to, 0 doesn't equal to 10, so we just say 15 here, 15. 15 and current, which is 10, so we are, you can see like 15 and 10, right? So we are here, 15 and 10. Then we update the previous to 10. We go to the next one. -8 means we need to push 8. We kind of like push, right? It's kind of like illustration, right? You better understand how it is going into that queue. So previous equals to 10. Current equals to 10. And previous equals to 10, so we just skip this step. We go to the next one. We here. 10 means that we need to get rid of 10. We say that current equals to 8, because 8 is greatest element into that queue. And previous equals to 10, so we just say 20. And 8 right here, 20 and 8. You can check this out, 20 and 8 right here. We are 20 and 8 right here, this point. Then we finally need to, before we need to update to 8 right here, and we go to the last element, which is 9. That means that we need to get rid of the 8. We say current equals to 0. and previous equals to 8, so we just 24, right? 24, which is 0. 24, which is 0. 24 right here, which is 0. So what we have is that you can make sure that I done no mistake. 10, 2, 10, 3, 15, 7, 12, 12, 0, 15, 10, 28, and 24, 0. That's it. And thank you guys for watching. Leave your comments below. I want to know what you think. Subscribe to the channel. Give me big thumbs up to support it. I do all LeetCode problems. Follow me on social medias, Instagram, Snapchat. I wish you all the best. Do your best and forget the rest. Keep going, never give up, and it's up to you. Thank you. Have a good one.